Okay, this is section 12.4, and some of you have been copying the rules down that you see up there. There's two rules. The derivative of e to the x, and we need to remember that e is a number, but usually it's not written as a number, it's just written as e. It's actually about 2.7, and it's got a ton of numbers after that. It's an irrational number, but it's a really important number. So you'll see it in calculus a lot. The derivative of e to the x is just e to the x. Wow, that's an easy one. You hope for those. Okay, that one's easy. The derivative of e to the u, that means when that exponent is anything other than a plain old x. If it's 3x plus 7, if it's x squared, that's e to the u because it's something more than x. Well, the derivative of that is e to the x, just the original, whatever that is, times u prime, meaning you take the derivative of the exponent. Okay? And actually, that should not be e to the x. That'll be e to the u. And it won't erase for me today. There we go. And that's a red. We start out with problems, don't we? Okay, so it'll be e to the u. So erasers, yeah, get that. All right, so let's look at a couple of examples and just see what we're talking about. You start out with e to the 5x. That's not a plain old x, so we do have to take the derivative of the exponent. So we write that down as it is. There's your e to the u, e to the 5x times the derivative of 5x. Well, the derivative of 5x is 5. So we have 5e to the 5x. You don't have to write down all those steps when that really begins to click for you. You can look at that and say, oh, I know the derivative of 5x is 5. That's going in the front. It's 5e to the 5x. Does that make sense? Okay. So move it up a little bit. So we have the next one. Y equals 10e to the 3x squared. So if you're going to take the derivative of that, write down the original thing just as it is. So we have 10e to the 3x squared times the derivative of 3x squared. The derivative of 3x squared, 6x. So now we have this. The 6 and the 10 can get multiplied together. The x goes in front usually. That's just kind of convention. If you had it all there for me on a test and you had all those pieces, maybe they weren't in the right order or the conventional order, they'll still be okay. Sometimes we'll have to watch it on Math Lab and figure out what they're expecting. But for me and for most things, the order is not going to be as important. But you would get 60x e to the 3x squared. Everybody okay with that? All right. Then we get two more rules. And these are the four that we get for this section. We had e to the x. This is a to the x. Yes, ma'am.
Are there like names for these rules? Like the product rule?
Not like the product rule and quotient rule. They're exponential derivatives. Like that's the e to the x, and this is the natural log. So I'm not sure. There's wonderful little names for them. Sorry. A to the x, that means any number besides e, like 2 to the x, 5 to the x, pi to the x, just a number other than e. And so if you have that, the derivative of it is ln, which is the natural log of a, whatever your base is, times a to the x. Okay? And if you have a to the u, again, something other than x, you're going to have ln a to the u, and then you're going to multiply it by the derivative of u. So it's very similar to e to the x, except that we get this ln a business coming in. Okay? Let's look at those. So if we had s equals 3 to the t, doesn't have to be x, it's just some variable. There's a number raised to a variable. S prime is equal to ln of A is 3, so ln 3 times 3 to the t. Because this wasn't 3 to the u, there wasn't anything we could take the derivative of, and if you did, you'd get 1, so it doesn't make any difference. So it's just ln 3 times 3 to the t. Okay? It's an easy one. All right, here's another one. 8 times 10 to the 1 over t. This is a little bit more complex. Let's see if I can make this screen a little bigger for you. Okay, so we're going to write 8 times, because the 8's just a number, it's just going to hang out there. ln 10, because that was ln a, of 10 to the 1 over t. Well, now we've got to take the derivative of the exponent, the derivative of 1 over t. You need to think of that as t to the negative 1. That way it'll be easier to take the derivative of it. Okay? So we've got this business here, 8 ln 10 times 10 to the 1 over t times, all right, the derivative of t to the negative 1. The negative 1 comes to the front, t to the negative 2. You drop down 1. Okay, so that's just like what we were doing yesterday. Okay? Now, from that step to this, the only thing that happened was the negative goes to the very front, and this t to the negative 2 I put on the bottom, t squared. Generally, they want answers without negative exponents, generally. Okay. Again, if on a test you got this far, I probably would be okay with that. I'd like you to get used to this, and if we had a lot of time and a semester, I would probably make you do that, but if you forget, you're going to be okay. But just keep in mind, you want positive exponents most times. Questions on that one? Anybody? Okay. All right, then I think we are ready to look at the problems out of 12.4. So if you'll go toward that. Oops. I need to, this is going to be great for the video. I'm going to turn this around. So when you're watching this video and you watch it go upside down and right side up, that'll be fun. It has to orient itself, and I don't know why it can't just do that. I might stay there. Okay, so the first problem is y equals e to the negative 10x. All right, so y prime equals, we're going to write that just as it is, e to the negative 10x times the derivative of negative 10x. Okay, so that's our kind of roadmap that we do. All right, so the only place we have to take the derivative is right here, and what's the derivative of negative 10x? Negative 10, thank you. Okay, so y prime equals e to the negative 10x times negative 10, and usually that's going to go to the front. So that's our answer for that one. Okay. Questions? Is that okay? Okay. Number 2, f of x equals negative 4 e to the negative 2x. So remember, you write the original just like it is. So f prime of x is equal to negative 4 e to the negative 2x times, what's the derivative of negative 2x? negative 2. All right, and then we're going to multiply negative 2 times negative 4, and we get 8e to the negative 2x. So be careful on your signs. You know, sometimes Math Lab's not going to count it right at all if you have the wrong sign. On a test, if you wrote down negative 8e to the negative 2x, it wouldn't be totally wrong. It's not going to be totally right. So you want to watch your signs, okay? All right, e to the x to the fourth. E to the x to the fourth. We're going to have the original times the derivative of x to the fourth. What is the derivative of x to the fourth? 4x cubed. Okay. So, and actually, I think in Math Lab, they let you leave it like that. I don't know if there's parentheses, but it's that order. I would always do it where the e to the x thing is at the end. But for Math Lab, it looks like I think that they want it that way. So either way for me on a test. And actually, for me, I would probably not even have the parentheses there. Okay. Number 4. Number 4, you have to recognize that that's a product. People start forgetting that. They're just looking at it and they're trying to do stuff. It's a product. So you have to write the roadmap out and do your product thing. I've written that out. It's x cubed times the derivative of e to the x plus e to the x times the derivative of x cubed. So you're only taking the derivative here. Whoa. I didn't get my little highlighter. Sorry. And here. Okay? So those are the only two places you're actually taking the derivative. All right, so what do we have? We have y prime is x cubed times, what's the derivative of e to the x? E to the x. That one's nice. Plus e to the x times, what's the derivative of x cubed? 3x squared. Okay. Let's see. I think for Math Lab, x cubed e to the x plus, they did put it in front, e to the x. Okay. You could, and a lot of times if you are in another course or you see it again in calculus, if you have to take any more, you might factor out what you could there. You could factor out x squared e to the x, and just to, that would look like that. So that's just simplified a little bit more, but Math Lab lets you put it in like this. Okay? So you're using those rules that we got yesterday, the product rule, and we're about to do the quotient rule. Those are, anytime you take derivatives, you've got to remember those rules. Okay? We're just getting different little pieces of information today with the e to the x. All right. Quotient rule. And within that quotient rule, we have to think about when we take the derivative of 4e to the 2x, we have to do that new rule that we got. So I've written out the roadmap for you. It's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Uh-huh. No, you didn't, and you're the only one that's awake. I meant to say that. Number 5 is omitted online, so mark that one out. I took that one out. I know you're sad, but yeah. And I meant to say that. I was just on a roll here. Okay. All right. So we'll go on with this one. Y prime equals 9x plus 2. What is the derivative of negative 4e to the 2x? It's this thing. You would write that down times what? Because it's the original times the derivative of the exponent, which is 2. Okay? Minus negative 4e to the 2x times, what's the derivative of 9x plus 2? 9. Okay. Okay. So then it's a matter of doing this multiplication, just multiplying. So we have 2 times this is negative 8 times this. So what are we going to end up with? We should end up with negative 72 e to the 2, let's put the x in there first. X e to the 2x. Everybody see where I got that one? I multiplied 2 times this thing. That'd be negative 8 e to the 2x, and then I multiplied it by 9x. Plus, no, not minus, it's minus because that's a negative 8. Minus 16 e to the 2x. That's multiplying negative 8 e to the 2x times 2. So this has just actually been combined. Minus, what's going to happen to that minus? Turn into a plus because we've got a minus minus, so that's going to be plus 36 e to the 2x over 9x plus 2 squared. Okay. All right, can we combine, do some combining here? These guys are the same base, so negative 72, do a little bit more room. Negative 72 x e to the 2x plus 20 e to the 2x over that. I used to always forget to write the bottom because I got tired of doing it, so I'd forget it and got me in trouble a couple of times. All right, is there anything else that I could do to this top part? Do you see some common things in there? In 72 and 20, is there a number I could factor out? 2? How about 4? I think 4 is probably it that we could take out. So we know we could take out a 4. What else is common here? Okay, so if I took out 4e to the 2x, then I'm left with negative 18x plus 5 over this. And that's the answer. Questions on that one? And I actually didn't give you any problems with the LN rules, okay, on the homework. No questions? Okay. Let me stop that one.